thank you for joining. I'm Kurt, as Nicole just said. Yeah, let's kick it off. So I'm here to talk to you about project planning with critical paths. And primarily it's a way to organize projects and sort your priorities. And I find it a very useful tool when it comes to project planning. And I hope that after this talk, you guys will kind of agree with me. So first, let's go into what it is. Yeah, at its core, it's a method of organizing a complex project's interdependent tasks in such a way that we can derive useful insights from them. So some of these insights that we're looking to obtain is the minimum time to completion, and not only obtain a minimum time to completion, but have a basis for that and be able to explain it at least in some meaningful way. We want to identify the critical lines of work. And by critical lines of work, I mean lines of work that should they be delayed or hindered in any way, they would delay or hinder the overall timeline of the project as a whole. We want to know which tasks to prioritize, how to allocate our resources, how best to schedule multiple teams, and how to evaluate risk. And throughout this talk, we'll be using this example of building a house, which I think is a reasonably complex example that can help guide us. I want to call out, though, that it is not just for one-off projects. You can use this to improve reoccurring processes. An excellent example of this is like doing a recurring deployment in which you have some downtime. If you want to minimize that downtime, you can use critical path to identify the best way to do that. And if project planning just isn't your thing, then you can use it to optimize concurrent software. But if you're here for a series of talks on project planning, I would hope that that is what you're looking for. And then it also scales well to all organizational levels, whether you're looking at a regular plan or whether you're kind of trying to plan across an entire organization. In both scenarios, it works pretty well. So let's look at our example of building a house in a little bit more detail so that we can kind of know what we're looking at. And then from there, we can try to break down and kind of dig into some of the insights that we find from this project graph. So looking at this, you'll notice that there are two sets of colored boxes. We're going to ignore the white boxes off to the side for now. Each of these two sets of boxes represent discrete tasks that need to be completed in order to, in our case, build our house or complete our house, but in more general to, advance the goal of completing our project. The arrows in between the different tasks or boxes indicate dependencies between tasks, with the the start of the arrow being the parent task and the end of the arrow being the child task. And when I say parent and child, I mean that the parent task must be completed in its entirety prior to the start of the child task. In other words, the child task is dependent on the parent task. Now, if we look into the boxes individually, you'll see two fields. You'll see the title of the task, that is just what needs to be done. And then you'll see a number, that is the time estimates. In this case, we're using days. I think there's a quick disclaimer here. I don't know how to build a house. So if the times don't look right to you, don't judge too hard. It's just an example that works pretty nicely for my purposes. But I will say I lived in a neighborhood where they were throwing up cookie cutter houses left and right, and about a month seemed right to me. So that's what I went with. Yeah. So, and I think another important call out with that is that the numbers are in terms of time, not cost. And normally those are often kind of correlated, but that is not always the case. A solid example of this would be like pouring concrete for a foundation or a sidewalk. Like there is the process of pouring it, and that takes time, but then you also have the process of just letting it cure, which takes a fair amount of time. You can't really speed it up, but it doesn't really cost anybody anything. And we're really more concerned with the overall time. You'll notice that some of the nodes or tasks are light blue and some of them are red. The red are the critical tasks. These are the tasks that need to get done on time. And the path through those red nodes is what's known as the critical path. So we have our project graph as a whole, and then we have the critical path, which is what we're really concerned about in this talk. So we're gonna keep it moving. Let's look at some of the insights that we can get right off the bat. So the first one is that we have a pretty critical chain of tasks that need to happen at the beginning of the house, that need to happen before anything else can happen. So of course we need to excavate the house, we need to lay the utility lines, we need to put the foundation down, and we need to do the wooden frame. And all of these are pretty heavy tasks. And this means that if we want our project to go off without a hitch and meet our deadline, we really need to schedule the start of our project really far ahead of time, make sure that the employees that we have, our teams are available, or that the contractors that we're contracting out to are available. And like, because there is so much work there, we really just need to kick the project off to a good start. Another finding is that the exterior work, kind of the landscaping, the sidewalks, the sprinklers, the gutters, there's a lot more slack in that. There's more flexibility. And I guess I should quickly call out, I did go a little bit too far ahead of myself when breaking down the project graphs. I skipped over the white boxes. The white boxes are attached to the nodes. They have two numbers in them. There is the earliest finish time. That is the earliest time that you can complete a given task. And then the lower time is the slack. That is the time that task can be delayed before it would affect the overall timeline. And that delay can come from either a parent task being delayed, a change in scope, a just delay in the task, or maybe just a scheduling conflict that needs to be resolved. And in the wild, you may see a couple different formats. Rather than earliest finish time, you might see earliest start. I mean, if you were to see somebody else's project graph, instead of slack, you might see latest start or latest finish. You can derive these three values from the information on the screen. And then you might also see discrete start and stop nodes, which are these zero cost nodes that just help kind of organize the graph a little better. I didn't do that because space is at a premium. But back to our insights, we kind of know that the exterior work is more flexible. There's a lot of slack in it. And so we can those teams are less critical. We know that when building our projects, the masons and the carpenters are absolutely critical. They have a lot of work, and a lot of that work falls on the critical path. And so when our company is making hiring decisions, if they're looking at the building of a house as a process as opposed to a project, which for a housing developer, building a house is more of a process, they know that they really need to have their masons and carpenters on lockdown, whether that means employing more masons and carpenters or paying subcontractors more, just building better relationships. We really want them to, we really want to make sure that we put a lot of emphasis, and that there's kind of less emphasis on the landscaping and roofers because they're not as critical to our timeline. We can also gain some pretty useful scheduling insights. And this is really important for a team like a construction company, which has a lot of kind of heterogeneous teams, in the sense that these teams have a lot of different skill sets. So you may have masons, plumbers, carpenters, electricians, painters, all of these people, they can't do each other's work. So you need to schedule between these teams across possibly different across different projects or construction projects. And we can see some useful things that may help or may assist in this scheduling. The first is that the plumbing can be clustered. We have a lot of flexibility for the basement, that kind of initial foundation plumbing. And if it works out for that plumber, maybe you can do that towards the end of that slack period and cluster it together. We find that the masonry has a lot of work. It's very critical for that very first part of the project. But once they've kind of laid the foundation, the additional work like laying the sidewalks and doing the brickwork has a little bit more slack to it and isn't as high of a priority. And if there's, say, another house whose foundation is being laid at about the same time, they should maybe prioritize that ahead rather than trying to finish up all the work at this house. And we find that carpenters are absolutely critical to this thing. They have to put up the wooden frame. They have to do some of the internal carpentry, like, finishing the trim, putting up cabinets, all of this, but they're not needed at the very beginning of the project. So we don't want to have our contractors show up and the foundation still be drying and there's nothing that they can do. And this is a very useful thing to be. This is very useful for organizations like construction companies to plan. And of course, you can use this in your own software planning. And now that we've kind of seen some of the insights, let's talk about how to build the project graph and identify the critical path. There's 8 discrete steps. We're going to look at them individually, so don't try to process them all right now. And let's go through. So the very first thing that we need to do is kind of answer a pair of questions, establish a time scale and a level of granularity. I think these are somewhat self-explanatory, but of course the project graph from an individual's perspective is going to be very different. Say I'm using critical path or project graphs to plan my own day. That's going to look very different from like an inter-organizational level. And then a project manager is probably operating at kind of the pod or team level. So this influences the size of the task and kind of the time scale. And in true A-Flight fashion, as I go through this, I'm going to be building a multiplayer tic-tac-toe server as our project that we're going to break down. Not the most exciting game, probably the worst multiplayer game I could have picked, but it serves our purposes. And you can see that there's a lot of discrete tasks to be done. And that brings us to our next step. Well, I guess we're going to use kind of the pod or team level of granularity for this, and we're going to use like half days as our level of granularity or our time scale. And so we have the first kind of obvious step. We need to identify these 15 tasks, and we'll be able to look at these a little bit further, but I think that's the most straightforward part. We need to identify the dependencies between the tasks, and then we need to rearrange the graph and draw the task dependencies between them. And just a reminder, the arrow goes from parent to child, or the parent task needs to be finished before the child task is complete. And our goal is to complete something called a directed acyclic graph. And that brings us to our next step, in that we have to refine the graph a little bit. And the most important thing here is that we cannot have a circular dependency, whether it be direct. So if task A is dependent on task B cannot be dependent on task C, or, and it can't be indirect either, meaning task A can't be dependent on task B, B to C, A to C, or, So we want to break these dependency chains when they arise. There's a couple different strategies for going through this. Sometimes if you have like a task A and B that are dependent on each other, it's because you don't have enough granularity in your project graph. And if you break them up, you can often break this circular dependency. That's kind of the first example above. Another possibility is that task A and B are really not distinct tasks. They're kind of should just be a single atomic unit. So we can go through and break that up or merge them together. And then a kind of more niche one is perhaps A and B aren't really dependent. They're just mutually exclusive, meaning they can't be done at the same time. In that case, you want to just pick one kind of arbitrarily and maybe make a mental note of it, or a physical note on your project graph. An example of this in our building the house might be you don't maybe want to do the flooring and the painting of a wall at the same time. That's probably a great way to get stains all over your carpeting, or maybe you just don't want the contractors kind of bumping in and getting in each other's way. So in that case, you just want to pick one. And in our example, we actually have a circular dependency. It is the back end CI/CD, or continuous integration, continuous deployment task. And we really want to break that into two distinct tasks. And we break that into the backend CI task and the backend CD task. And one of the nice side effects of this is that it actually makes our project graph a lot cleaner when you're done. You notice like there's a bunch of crisscrossing lines like prior to this. So that is a nice side effect of it. And we actually have done this twice in our project. There's another front end CI/CD task that has the exact same problem. I won't go into that. The next step is somewhat optional. We need to eliminate duplicative dependencies. So if we look at our example to the right here, we have the staging deployment, or the staging deployment is a parent task of the product deployment. And we see that arrow, but if you notice, it's actually somewhat duplicative. It's implied by the dependency on the backend continuous deployment task that is also dependent on the staging deployment task. And so we can remove that task dependency if we want. This isn't strictly necessary. And the one time that you may not want to do it is if you have, if you're unsure of what your project graph looks like and you think, oh, we might make changes, you may not want to inadvertently lose that dependency if you rearrange it and then forget to redraw that line. In graph theory, this would be called transitive reduction for the nerds out there. But once you have that, we can kind of go to the kind of the difficult part of critical path, which is the estimating the tasks and then computing the longest tasks. We're going to go through those steps in English up top individually, but I think the first thing that we need to do is estimate the tasks. That's pretty straightforward. And then we need to go find all the start tasks or the parentless tasks, and we need to kind of assign them a earliest finish time, which is just their time estimate, right? So here we go. We got the backend CI/CD. We do the same one for the API contracts. We do the same thing for the UI design. We do the same thing for the front end CD. Pretty easy first step. Next thing we need to do is we need to go through each of the tasks such that the parents' times are all finished, and then we need to set the earliest finish time of our kind of target node to the longest parent task or the latest parent task plus the time estimate. So that's a lot of word soup. So let's kind of quickly look at what that looks like in practice. Here, we're going to look at the game logic task, or the implementing the game logic task, and it has two parent tasks or two dependent tasks, which is the API contract task and the backend CI task. The API contract task has a longer or a later earliest finish time, so we're just going to ignore the backend CI task, and we're going to take the 2 from the API contracts time, and we're going to add it to the game logic's time, and we're going to get 4. Luckily, login sessions uses the same time estimate and has the same parents, so it is also 4. We then go further down the row. We have the login UI task, which is dependent on the UI design, and the front end CI task. The UI design task is the longer task, and then we have the time estimate, so we add those together to get 6. Game UI is very much in the same boat. And now that we've done that, we kind of iterate over each generation to get and kind of flood fill it. So next, you can see we do the same for the game API and the front end staging deployment. We do it again for the front end CD and back end staging deployment, and we're just going to jump ahead until everything is filled in. Sweet. And then finally, we need to identify the critical path. So we look for the terminal task or the last task that finishes the latest, right? And in this case, we just have a single one. It's flip the switch, so we highlight it red. There is only one parent task for the flip the switch, so of course that has to be into the critical path. So we also highlight it red. Now we have an interesting scenario. We come to a branch between the back end production deployment and the front end production deployment. The front end production deployment gets finished later, so we're going to branch off to that side, and we're going to highlight the front end production deployment, and we're gonna kind of ignore the back end production deployment. And we're gonna once again highlight the parents, pretty easy. We have a little bit of a trick up here. We have the login, the front end staging deployment has two parents. There is the login UI and the game UI. They both have the same earliest finish time. And so we actually want to highlight both of them. And this is kind of this kind of highlights a broader point, is that you can have multiple critical paths within your project graph. There's no reason that it needs to be the same. And finally, we get to UI design, and we have now highlighted our critical path. Yeah. So let's just quickly review the steps. We need to establish a level of granularity. We need to establish a time scale. We need to identify the tasks that need to be completed. We need to identify the dependencies. We need to refine our tasks and dependencies. So break those circular dependencies, perhaps do a little transitive reduction or get rid of the duplicative dependencies. We need to estimate the tasks. We need to compute the longest path. And then we need to identify the critical paths. So now that we've kind of built the project graph and we kind of know a little bit more, maybe have a little bit better or more intuitive sense of the project graph, let's look at some of the insights that we can get from mutating it. And for this, we're going to go back to our housing example. So refamiliarize yourself with this. One of the maybe most important question that you'll probably get as a project manager or somebody who's doing project planning is, how can we speed this task up? And the answer lies in the critical path. We want to divide the critical path or try to shrink it. And we actually don't care too much about the non-critical tasks. For example, we can try to speed up the landscaping, but it's not going to speed up all the work that needs to be done in the house. And so we don't really get the benefit. And that's an important call out, because sometimes splitting the task does have a cost. There is often an overhead to parallelizing work. For example, if you break a task into two different tickets when doing software development, you may have to do kind of the whole development process over with the peer review separate. You have to get people to do the peer review and the QA twice. There's an overhead to that, and that's not free. And so splitting up the task has a cost. It is not free, and you really want to do that on the critical path where it makes the most sense. So let's look at our house. We're going to divide the critical path. And I think the logical way to do this, or one of the ways you could do this, is let's break it down by floor. So we have the plaster, we have the flooring, we have the carpentry and the bathroom fixtures, and we just have this for the entire house. We could do this floor by floor and add a little bit of parallelization. So let's see what that looks like. So first, we're going to look at the plaster. We're going to break that up into an upstairs plaster, main stairs plasters, kind of putting up drywall, finishing it all up. And we break that up into two tasks. A very important call out is that this only works. This only works if you have two teams to actually do this in parallel. If you just have one person or one team doing this, this is nice from a theoretical perspective, but it doesn't actually speed up your project. But if you have capacity to spare and you want to effectively use that capacity, you can split this up into the main floor, and we can keep doing that for the dependent tasks. You'll notice that when we did this initial split, our earliest finish time got a 1 day quicker. So moving along a little faster, we can do the same thing with the flooring. You can see the critical path has once again gotten 1 day shorter to 26. And finally, we're going to quickly jump ahead, and we're just going to break up all the tasks. And finally, we see that the critical path is 25 days. So we've broken up the main floor carpentry, the bathroom fixtures, and the painting all into separate, all by floor. And we've actually shifted the critical path. I think an important call out is not only is it shorter, we've also, because we've made it shorter, we've actually shifted the critical path, or we've created another critical path in the landscaping. Now the landscaping work has a potential to be a bottleneck. And we've done that by cutting down the slack in the kind of landscaping bottleneck. Yeah. As I kind of went through before, this will require additional labor. So it doesn't come for free, but if your priority is to get the task done as quick as possible, then this is the way to go. Another way that you may mutate the project graph is you want to add scope. And let's say our client or person who's building this house, has a couple of different requests and they want to know how it will affect the project timeline. And one thought is, hey, I want fancy landscaping. I want a water feature. How will that affect the timeline? And then the same thing for adding heated floors to the main floor. How will adding that to the scope affect the overall project timeline? And we find that if we look off to the far left of the graph, we have kind of the drainage and the sprinklers and the walks. Well, we could kind of insert a water feature there, and we have enough slack in those tasks that it doesn't affect the overall project timeline. As long as we have a team available to go with the right skills to put in our water feature, our fountain, we want a big one with rocks and everything, then it won't actually affect the project timeline. And this is a really useful way to grow the scope and maybe, effectively allocate resources within your, effectively allocate idle teams or idle hands within your organization. Now, if we try to add the same thing, we try to ask the same question for the main, adding heated floors to the main floor, we find that the main flooring is on the critical path. And if anybody, adding a heated floor is kind of a complex task. You kind of have to lay out all the wiring and the grout and maybe put some tile down. There is just no way that is not going to extend the project deadline, and you can explain that. And I think this kind of gets to a really useful part of the project graph and the critical path method is that, commonly in software engineering, there is this feeling of, well, we're going to speed up the project. We're going to add scope to the project. And the way we're going to combat that is, well, we're just going to throw more bodies at it. And sometimes as developers or as a project manager, you kind of intuitively know that's not really going to work. Well, the project graph can provide a reasonable explanation for why that is, and kind of explain why maybe the Mythic Man month doesn't work in a more tangible way. And finally, we're just going to wrap it up here. I have more to go, or I would love to keep going, but I don't want to take up all of Martin's time. So, but just a quick review, we defined the critical paths. We kind of explored the goals. We used building a house as an excellent example of this. We constructed our own project graph with tic-tac-toe. We updated the house project to, incorporate changing needs. And then if you're further interested, if you have more interest in this topic, one thing I kind of omitted was calculating slack just to time constraints, which is a really useful metric. And then PERT is a kind of critical path on steroids. Critical path is more of a deterministic model. PERT tries to take confidence into account and really project, give better time estimates and kind of a better range for how long a project would take. So if you want to dive into this, PERT is an excellent place to go.